So far, we have um, some hot metal and some water. And now what do we do next? Here's what we do next. We need to know the amount of heat that came out of the metal and that went into the water. That's what we have to do. We need to know how much heat came out of the water and into the water. I'm sorry, out of the metal and into the water. How much heat came out of the metal and into the water. So when the metal is in here, how much heat went into the water? We know the temperature of the water. We know how much the temperature changed, but that's not the same as heat. Remember, heat and temperature are different in that heat depends on mass, but temperature does not. All right, so anyways, let's now calculate the heat. To do that, you must memorize this equation. This equation will not be given to you on your quiz or your exam. You must memorize it. Some people like to memorize this as Q equals MCAT. This is not an A, this is a Greek letter delta, meaning change. The Q of this equation means the heat. This is how you calculate the heat. Heat depends on three things. Well, this equation is for heat transfer. So the heat that gets transferred from one thing to another, like the hot metal to the water, it depends on three things. It depends on the mass. It also depends on the specific heat capacity. And it depends on the change in temperature. Delta T means the change in temperature. Okay? If you experience a very large increase in temperature, well, that means that a lot of heat got transferred. If you have a large mass, then that will allow you to transfer a lot of heat. If you have a very large specific heat capacity, and that means for even a small change in temperature, you're going to need a lot of heat. All right, now I have written this equation, and I will now use it, and you will use it in the same way if in the homework. So please watch this. I'm going to calculate the heat that got transferred to the water. W is for water. That means I need the mass of the water times the specific heat capacity of the water times the change in temperature of the water. And what are those? Well, here they are. The mass of the water was this. The specific heat capacity of the water is a constant, and it is only one number for us in Chem 65. However, if you major in chemistry, you will find that the specific heat capacity is different when the temperature is different. But for Chem 65, we will always just treat specific heat capacity as one number, a constant number. And for water, the specific heat capacity is 4.18 joules per gram per degree Celsius. These are the units. Joules per gram per degree Celsius. Right? Joules divided by grams divided by degrees Celsius. This only has three significant figures. The specific heat capacity for water can have more significant figures. It just depends on who measured the specific heat capacity and how they did that. I think in your textbook, most of the time they're using this number, 4.18. I have seen 4.184 in some textbooks. I have seen 4.1816 in some textbooks. This is used when the specific heat capacity is different for different temperatures, but that's nothing for you to worry about at the moment. Right. So let's go back to the calculation. What about the change in temperature? The water was this temperature. Now it's this temperature. So how do you calculate the change in temperature? You calculate the change in temperature by doing this is T final minus T initial. That is how you calculate the change in temperature. So T final minus T initial. It was 34.1 was the final and 23.1 was the initial. So that's going to be easy to calculate. Let me just plug these numbers in for you here. Was it only to the hundredths place? Did I only have it to the hundredths place? No, I had it to the thousandths place. So I need one more one here. So 100.111 grams times 4.18 joules per gram per degree Celsius times the delta T. which is 34.1 degrees Celsius minus 23.1 degrees Celsius. And so when I do this, of course, I need to do the things in parentheses first. And the answer to this is just 11.0 degrees Celsius. Your calculator says 11, but of course you know that to respect the significant figures, the answer cannot just be 11, it's 11.0. So that is a 3 significant figure number. This is also 3 significant figures, and this is 6 significant figures. That means the answer is going to be in only 3 significant figures. By the way, if this were to be 4 significant figures, then you would have to change the C. You would have to use the C that has 4 significant figures. Your constants should have at least as many significant figures as your data, preferably more significant figures than your data. Okay, I'm going to calculate this now using my calculator here. So 100.111 times 4.18 times 11.0. Well, calculator doesn't care about the 0.0. The answer here is 4,603, but how many significant figures am I allowed? Only 3. So the answer is really 4,600. And what are the units for this? Well, the grams cancel, and the degrees Celsius cancel. All that are left is joules. Joules is the unit for heat. It's capital J. So in scientific notation, there were 3 significant figures. So this is the answer in scientific notation. Okay? What is the meaning of this? This is the heat energy that the water absorbed. So the water here absorbed 4,600 joules of heat energy from this hot piece of metal. That's a nice answer there. However, that is not the answer. Why? Because in this problem, you remember, I was looking for the specific heat capacity of the metal. Well, I wrote all those things underneath this page, so I can't go back to them. But I want the specific heat capacity of the metal. So here's the specific heat capacity of water, 4.18. But what is the specific heat capacity of the metal? How do you figure that out? I'll be showing you that in my next video. Thanks.